Okay, here we go. So today we are talking about two different lines like we have been in the past, but we're not going to do so much graphing today. I want you to start with page 319, so make sure that everybody is on page 319. We're going to work with linear equations, and today we're going to work with variables on both sides of an equal sign. We're going to write a systems of equations, we're going to solve it, and interpret it. We'll get to that part then tomorrow. I want you to take a couple minutes to work through these 4 problems. Pause the video, take some time to work through these problems. Now that you're back, I'm going to go ahead and show you the answers and see if you got them correct. Make sure you're using a calculator. Make sure that you are showing your work. Make sure that you are checking your work to plug things back in. This is all a review from 7th grade, so this should all be things that you remember how to do from last year. All right, turn the page to page 320. Colleen and Jimmy want to see how much money they can save in one semester by placing part of their earnings each week into a savings account. Colleen has $120 in her account, and she will save $18 each week. And then I've got Jimmy has $64 in his savings account, and he will save $25 each week. We're going to write equations for Colleen and Jimmy that represent the total dollar amounts. This is something we've been doing. So if I look at Colleen's, it's going to be y equals, what is the number that stands alone is going to be my 120, so it's going to be your 18x plus 120. So she starts with 120, she gets $18 each week. When we then talk about Jimmy, again, we have y equals, he's going to start with $64, but he is saving $25 each week, so plus 64. Okay, this is something that we have been doing for a really long time, so you should be very familiar with this. Now, the next question asks you to interpret the rate of change and the y-intercept for each equation in terms of the context. Well, you've got Colleen. When I think about Colleen and Jimmy, I think about their equations. Now remember, your y-intercept is the location where these both start. So where do you start on the graph? I start with Colleen at 120, and I start on the graph at 64 with Jimmy. So for number 2, make sure you have Colleen's written down at 120 and Jimmy's written down at 64. Okay, so what that means is who has saved more money, Colleen or Jimmy? Right, Colleen has already saved more money. Next, we talk about more money per week. Which person is saving more money per week? I remember my per week is when I talk about my slope. Who has the larger slope? Who's saving more money every single week? Well, in this case, that would be Jimmy, because Jimmy is saving $25 every week, where Colleen is only saving $18. However, Colleen started with more money. Okay, so question number 4 asks, do we think that Colleen and Jimmy will ever have the same amount of money in their savings account at the same time? Well, eventually, I would say yes. Why? When we've worked with graphs before, what's going to happen to the 2 lines? They're eventually going to cross, right? That is going to be the point at which they're breaking even, the point at which they have the exact same amount. So I want you to take a minute and write that down. Pause the video, write down, will they have the same amount of money and why? Now, going down the end, you have to do number 5 as well. Which person do you predict will have more money in his or her savings account at the end of the semester? Well, a semester is probably 18 weeks in this case. So after 18 weeks, who do you think is going to have more money? So make your prediction for number 5. Write it down. Is it Colleen or Jimmy? You're choosing a name. Okay. Now we are moving to page 321. This is going to be our first activity. We're representing a problem situation with a subsystem of equations. So we've talked about this before. When two or more linear equations define a relationship between quantities, they form a system of equations. This is what we've been working on for the last couple of days. The solution to a system is the ordered pair. So just like in my graph, it's that place where they meet. That is the solution of both equations in the system. Graphically, the solution is the point where the two lines cross. Again, where we graph them, it's the two lines cross. That's their solution. Okay? All right. All right, so we've got those 2 points. Colleen and Jimmy, look at that. They have a nice little graph for us. Uh-oh. So they can write those 2 equations. They find the place where they meet. We can determine at what point are they meeting. Okay, so I'm going to take a look at this. Go right up. How many weeks is that going to be? So think about how many weeks it is going to be when they meet. And about how much money is that going to be? Okay, so we're going to determine the number of weeks at which they will have the same amount of money. And what is the amount? When I look at that, I see 8 weeks. Now, when I look at the amount of money, I know it's bigger than 240, and I know it's less than 320. So I can look through and say, okay, well, how much is this amount? How much is this amount? So 260, 280, 300. It's not going up by 20s. It's going up by a little more than 20. So I don't know. I might say it's going to be like 265. It might be about 265, 270, where they're in the same. In many systems, it says it's difficult to determine using a graph. And why do you think that this would be difficult to determine using a graph? This graph is perfectly clear. It's absolutely not perfectly clear. It doesn't show me exactly where it is. Okay, with graphs, you kind of have to estimate. There's another way to do this, and it's called substitution. Okay, so substitution is when I plug something in, and I'm going to work through it that way. So I've got my 2 equations. Okay, with my 2 equations, I'm going to determine, I like how they do them in color because that's how I do them. You're going to determine that both equations are equal to y. Okay? Well, y is the same thing. So what happens if I just get rid of my y's and I set these 2 equal together? Because does y equal y? Oh, that looks like a z. Does y equal y? It does. So that means that my 2 equations are also equal. So it says, what does the expression on each side of the new equation represent? So we want to find out when Colleen is equal to Jimmy. What are we saying about Colleen and Jimmy? What's going to be equal? Well, it's going to be the money in their bank account. Okay. When we solve for x, what will we know? Thoughts? You're going to know how many weeks it will be equal. And then is x going to be the solution? Well, it's going to be part of the solution. The reason why it's only part of the solution is because you need to know weeks and amount. What we will find is just the weeks. And then I'll show you how we can plug it back in to figure out the amount also. Okay, so what they did is they went ahead and they worked everything out here. Okay, so they've got their 120 plus 18x. They've got their 64 plus 25. Now, I like to think of my x's as superheroes. So I've got the 25, and his x is his superhero cape that follows him. Okay, these superheroes are buddies. So what we need to do is we need to put them both on the same side together. The numbers without a superhero cape, or the x, those are going to be your constant people. They're the numbers that also need to go together, but they are not the same as superheroes, so they need to go to the other side of the equal sign. So what you'll see is you'll notice that they subtracted 18 from both sides, and they subtracted because in the equation it says plus 18. So they have to do the opposite, so they subtracted 18. And whatever you do to one side to balance out the scale, you also have to do to the other. Now I've got 120 plus 0 equals 64 plus negative, or when I combine these two together, they give me 7. Now I don't even have to worry about that 0 because basically those two cancel out. They go away. So now I rewrite it, and I actually like to rewrite it like this without that 0 because I feel like sometimes it gets confusing. Now, my superhero's over here by himself, but we got to move that 64 over. And since there's no sign in front of it, what they did is they went ahead and subtracted. Now that I've subtracted 64, I've got a 56 equals 7x. So I'm going to subtract 64 over here. Those cancel. And that's when I'm left with a 56 equals 7x. Well, that's a one-step equation. 7 times what is 56? And it's going to be 8. So in 8 weeks, they have the same amount. So that is the x value for what I have. Now, 8 weeks is a great option, but it's not the whole thing. Let's see here. Okay, so now I have to determine the amount of money. Well, in order to do that, I just have to go into the equations. Oh, and this equation was, let's see, 18x plus 120. So Colleen's equation is y equals 18x plus 120. And I just told you that x equals 8. So if I go ahead and I plug 18 into 8, get out your calculator. We're going to multiply that together. So I'm going to take 18 times 8. And again, I'm going to get y equals 144 plus 120. Now I have to just add them together. And so y would then equal 264. Okay, now it says now that you know that the solution is an ordered pair. What ordered pair would it be? Well, guess what? I already told you that x is 8 And you now know that y is 264, so my ordered pair would be y, or 8 and 264. Now, we guessed when we looked at the graph before, but this is mathematically, algebraically correct. So we were close, but we weren't exact. So what we're going to do now is you're going to do lots of practice. You have a quizzes. This quizzes has 20 questions. Okay, you know that you have to get what percent or higher on the quizzes? That's correct, 80% or higher. Take your time. I want everybody to go get a marker, and I want you to use the table, and you can write on the table, and I want you to work out all of these problems so that you can do these correctly. Okay, take your time, work through the quizzes. You've got the time now to do it.